Welcome back, and in this video I'm going to be introducing you to a new way that we can measure angles. Many of us, the overwhelming majority of people are really only familiar with measuring angles in degrees. If I went ahead and said, hey, what's the length of this angle here, you'd be comfortable saying, I don't know, maybe like 40 degrees, 50 degrees, whatever. But that's not the only way that we can measure angles, okay? There's different units that we can use, okay? The same way that we can use different units to measure a length. Like if I said, hey, what's the length of this? You can measure it in feet. You can measure it in centimeters. You can measure it in centimeters. You can measure it in meters. You can measure it in miles. You can measure it in yards, etc., etc. There's a lot of different ways that you can measure a length, and everyone's totally comfortable with that. Yeah, feet, miles, yards, all kind of stupid, but centimeters, meters, kilometers, okay. We're very, very comfortable with the fact that there's different ways that we can measure lengths, okay. But a lot of people don't realize that we can actually measure angles in a different way, and one of those ways is radians, okay? And especially in mathematics, radians are very, very important. If you're in a pre-calculus class or planning on taking calc kids can definitely attest to using radians all the time, okay? Radians is definitely very, very big in mathematics, okay? And you're probably going, well, what the heck is a radian, okay? Well, a radian is kind of special, all right? We just covered arc length, okay? We just covered arc length, so this should kind of seem familiar. So let's say I had some circle and it had a radius r, okay? Just had some unknown radius, okay? A radian is actually a very special measure. A radian kind of comes from this. So let's say that this angle here was such that the arc length formed right here, that this length right here, this arc length right here, formed was actually equal to the radius, okay? So all of these are the same. This length here is equal to the radius of the circle. And you might be going, well, what degree measure would that be? And that would be a specific degree measure, but that's actually where radians come into play. We would say that this angle here is 1 radian. That's really what a radian is, okay? A radian is an angle measure such that the arc that subtends this circle, this angle here, is actually equal to the radius of a circle, okay? And that might sound kind of confusing, but it's really not that bad. All right, so let's say, so you might be going, well, how does this relate to degrees? How do I go back and forth? Well, let's say this. Let's say you draw an angle. Let's say you draw an angle and it's 1 full rotation. That's a terrible rotation. Let's say it's 1 full rotation. So you might be going, well, what would that be in degrees? Well, we can think about this. That would be an entire terribly drawn circle. That would be an entire circle, right? And think about what that degree measure would be. That would be a full 360 degrees, right? We're all very comfortable with the fact that a circle is 360 degrees. 1 full rotation is 360 degrees. Well, think about what the length of that arc would be. That's just circumference. That would be 2 pi r, right? That would be 2 pi r. Well, 2 pi r gets us what that length is. So we want to think about how many radiuses or radii would fit in that, because that's what a radian is. And the answer would be 2 pi radians. Because 2 pi radii are going to fit in that full rotation. So that kind of brings us to a nice little relationship here. 360 degrees is equal to 2 pi radians. And I can break this down even further. If I want, I can divide each side by 2. And now I know that pi radians is equal to 180 degrees. And I can go even further and divide each side by pi to get that 1 radian measure is equal to 180 over pi degrees, which works out to a little over 57 degrees, okay? And this right here is actually going to help us convert between degrees and radians, okay? Because that's something that's very, very important. Being able to go back and forth from degrees to radians, from radians to degrees, okay? And how in the world would we do that? Well, we actually kind of just found out. If we want to convert from radians to degrees, I'll just multiply the radian measure by this relationship right here. This is a conversion, the same way that we convert inches to feet and feet to miles, and say miles to meters, okay? We would multiply by some proportion, some conversion, okay? And that's exactly what we do here. So let's say I wanted to convert, let's say pi over 2 radians. What in the world, what degree measure is that? I wanted to convert pi over 2 radians to degrees, okay? And the way we would do that is we would take the radian measure, which is pi over 2, and multiply it by our conversion factor, okay? 180 degrees over pi. 180 degrees over pi. Because what would end up happening here is I would get pi times 180 degrees over 2 pi, and the pi's cancel, which leave me with 180 over 2, which is 90 degrees. So pi over 2 radians is 90 degrees. That's how we convert radians to degrees, okay? Let's say I want to do something else. Let's say I wanted to convert pi over 4 radians. Pi over 4 radians. What is that in degrees? Well, I would take my radian measure, which is pi over 4, and multiply it by my conversion factor right here, 180 degrees over pi, which would become 180 degrees pi times 4 pi. The pi's cancel, which leaves us with 180 degrees over 4, which boils down to 45 degrees. Okay, so pi over 4 radians is 45 degrees. So that's how we convert from radians to degrees. So we take the radian measure, and multiply it by 180 degrees over pi. That's going to be equal to our degree measure. Okay, and now you might be going, well, that's great, but how do I go from degrees to radians? Well, pretty straightforward, actually. Let's say I wanted to convert, let's say 60 degrees to radians. Well, how would I do that? Well, I would take the degree measure and just multiply it by this flipped. 1 degree is equal to pi over 180 degrees. Okay, so I would multiply 60 degrees by pi over 180. So I literally just flip this. Okay, so that would become 60 degrees pi over 180 degrees. The degree measurements cancel out, which becomes 60 pi over 180, which reduces to pi over 3 radians. Okay, so that's how I can convert from degrees to radians. To convert, I want to take the degree measure. Multiply that by pi over 180, and that's going to get me the radian measure. Okay, never mind how terribly I'm writing that. All right, actually, that's really bothering me. Let me rewrite measure. Radian measure. A little bit better. All right, so another example of that. Let's say I wanted to convert, I don't know, 200 degrees to radians. Well, I would take my degree measure, multiply it by pi over 180. That would get me 200 degrees pi times 180 degrees. the degrees cancel out, and 200 over 180 boils down to 10 over 9, so that would be 10 pi over 9 radians. Notice how I'm not actually multiplying through by pi. The pi is going to stay in the final answer. Okay, and that's how we convert from degrees of radians to degrees, and that's what a radian measure is. Okay, definitely practice with this. Definitely get comfortable with radian measures because we do use it very, very frequently in mathematics. Until our next video, goodbye.